Hello friends. In this video, we will learn about the normal distribution, the functions or the formula which we will use in normal distribution like cumulative density function and percent point functions. Along with this, we will discuss the central limit theorem and how to use all these things in real world scenario. See, we learn normal distribution because most of the real time scenarios, it revolves around continuous types of variables. And we can solve those problems if data is normally distributed. Okay, so we all know about the bell curve. Okay, so when we see this bell curve, we understand that this data is normally distributed. For normal distribution, uh, data is normal or not, we check the skewness and kurtosis, and the values for both should be between -1 and +1. In that case, we will consider that our data is normally distributed. Okay, so this is our symmetrical curve. And when this curve is symmetrical, when this is normally distributed, in that case, all the mean, median, and mode, they all will be same. So let's understand a few things about this normal distribution. The first thing is the area under this curve. The area under this curve is our probability. Okay, this is the same probability which we use in our hypothesis testing. So the area under this curve is probability, and which is always equals to 1. It is a symmetrical curve. Symmetrical means the mean is at the from the mean, the left hand side of the curve is equals to the right hand side. As we all know, the total probability is 1. The area under this curve is 1, total probability. So from mean, left hand side is equals to RHS, right hand side, and both are 0 0.5. It's simple. X-axis is asymptote to normal distribution. Asymptote means this curve will follow the x-axis, but it will never touch the x-axis. And the fourth thing is, what are the statistical parameters to define normal distribution? Answer is mean and standard deviation. We will never show mean alone. It makes no sense. So we have to depict standard deviation as well with mean. Okay. Now, let us suppose a scenario that we have students and their exam scores, student names and exam scores as fields or attributes. Now, mean of the exam score is provided to us, that is 494. If we take the average of average score of all the students, that is 494. And the standard deviation is also provided, that is 100. So if I make a curve, so this is the curve, okay, and the mean is, this mu is 494 is the mean, and standard deviation is 100. Now, the question is, what is the probability that a randomly selected score is between 300 and 600? What it means if I pick any of the student and if I check his her score, so what is the probability that his her score will lies or come between 300 and 600? So as we all know that this center point, this is our mean and it is 494, and we have to check between 300 and 600. So 300 will be, but obvious it will be on the left hand side from the mean, because mean is 494. 300 is less than 494. It will be on the left hand side, and 600 is greater than 494. So it will be on the right hand side. So now we have to find out this area, this colored area. What is this colored area? This is the probability. So we have to find out the probability. What is this probability that if I pick any of the student and then her score will come between 300 and 600. So we have to find out the probability. So we have to find out this area. So how we can find out? We can use one function. There is one function called CDF, that is cumulative density function. Now, what are the parameters we have to provide in this CDF function? In CDF, firstly, we will provide the value of x, then the mean, and then the standard deviation. So let us suppose I want this area from 300 to 600. If I if I count from the y-axis, if I check the distance or the overall probability from y-axis till 600, it is, I have named it A. Okay, total probability under the curve from y-axis to 600. That will be A. And the total probability from y-axis till 300, that will be considered as B. So if I minus B from A, if I do A minus B, so I will get this orange area. Okay, the probability for this area 300 to 600. How I will apply this? I will apply this by using CDF function. In CDF function, firstly, I will give the value of x. What is the value of x? Actually, I want to calculate the probability till A, and this value is 600. So I have provided the value of 600, that is x, comma, mean. What is mean? Mean is 494, comma, standard deviation is 100. So it will be stored or assigned in A. Okay, so this will be A. In the same way, I will calculate the probability for B as well. B is equals to CDF 300 till 300. The value at x-axis, comma, again the mean 494 and standard deviation 100. Now if I do A minus B, I will get the complete probability, this probability. So this CDF function will provide me the probability under the curve for the particular area. Now, this CDF function, we cannot use this function directly. This CDF function is inside the package SciP, okay, scientific Python. So inside this, we have a module called stats. In this scientific Python SciP, inside this we have stats. And inside this module stat, again we have another module called norm for normal distribution. And inside this module normal distribution norm, we have CDF function. So let's check how to do it in Python in our Jupyter notebook. So firstly, I have I'm going to import skype.stats. Skype.stats as st. Now what is this st? This is the object. It is the object of skype.stats. So now this st is having all the power functionalities uh, within this skype.stats we have. So I'm writing st. It means I'm writing skype.stats. So st.norm. Inside st, we have this module called norm, and inside this module norm is for normal distribution. Inside this we have CDF function dot CDF, and now I'm providing the value of x, that is 600, then the mean 494, and then the standard deviation, that is 100. Whatever outcome it will provide me, this function, CDF function, it will be stored or assigned in this particular variable, that is A. In the same way, I am calculating for the another x point, x value, that is 300, then again mean, then standard deviation. It will be stored in B. Finally, I am doing A minus B. So what A minus will be? The output will be the probability. So let me run this. Now see, this is the probability. 82.9%. So there is 82.9% probability is there that if I pick any random student, then her marks will come between 300 and 600. So this is how we can use CDF function, cumulative density function. So one more thing about this function. See, in this function, we provide the value of x and it gives us the probability. Okay, so keep this thing in mind. Now we'll discuss the central limit theorem. Now, what is the central limit theorem? Researchers they did one experiment. So this theorem, it is an outcome of one experiment. So let us suppose we have a population which is normally distributed. Then researchers took samples, small samples from this population which is normally distributed. So let us suppose the sample size was 10. So sample 1 in which we have data points x1, x2, x3. So we have 10 data points till x10. Now the researchers they took the mean of this sample 1. After that, they took another sample from the same population, sample 2, x1, x2, x3, x10, then they named it the mean x2. In the same way, they took a number of samples. So finally, when they checked out that the distribution of the means of the samples, it was normally distributed. It was normally distributed, even though the sample size was very small, that is 10. So when the population was normally distributed. Okay, population is normally distributed. This is population. When sample size was 10, so distribution of sample mean it was also normally distributed. So finally, scientists, the researchers, they increased the sample size from 10 to 50. When they increased the sample size, again they checked the distribution of sample means again it was normally distributed. Now, Now, they took another experiment. They took the population which is not normally distributed, not normally distributed. Okay, so population is not normally distributed. Now, they took the sample size, different samples, and the sample size was 10. So, in that case, the distribution of sample means it was also not normally distributed. But they found something very interesting. When they increased the sample size, n is equals to 50, I'm talking about when population is not normally distributed. But the sample size was adequate. Sample size was 50. In that case, the distribution of sample means it was, it is normally distributed. We can see this is normally distributed. So the the outcome is whether the population is normally distributed or not. If the sample size is adequate, in that case, our distribution of sample mean it will be it will be normally distributed. Okay, so it depends on sample size. Now how we will what is the parameter when we can say that sample size is adequate? So the answer is 30. If sample size is more than 30, we can say it is adequate. Now, so these are the outcomes of the central limit theorem. The sample mean will be equals to the population mean. Okay, if we have adequate sample, so sample mean will be equals to population mean. The sample standard deviation will be equals to the standard deviation of population divided by under root the sample size. N is sample size. And finally, our Z statistics. This is the formula we know. Sample mean minus mu divided by standard deviation under root N. Okay, so these were the outcomes of the central limit theorem. Now, uh, let's do a practical and find. Let's have one question and we'll try to solve it. Now, for example, there's a company called Mercury, And this company makes a 2.4-liter V6 engine. The laser XRI engines which are used in speedboats. Okay. The company's engineer believe that the engine delivers an average power of 220 horsepower. Now the company is believing that their engine they will deliver at least 220 horsepower. This is average, yeah. It means it is mean. Okay. And that the standard deviation of power delivered is 15 horsepower. So standard deviation is 15 of the population. Now, a potential buyer intends to sample 100 engines. Now, one buyer is interested to purchase their engines, but they want to check 100 sample and each engine to be run at a single time. So, the potential buyer, they want to check whether their engine gives 220 horsepower or not. Now, what is the probability that the sample mean will be less than 217 horsepower? Now, this we have to find out. What is the probability? We can consider it as a scenario where this company Mercury is checking their engines that it should the horsepower, the average power should not be below than 217. The sample size is 100. Now we have to find out what is the probability. The sample mean will not go beyond uh, go less than 217. Okay, so as the answer is, I have used my notes uh, to make it more feasible to understand. So now the as sample size is 100, which is above 30, so means it is adequate. And according to central limit theorem, if sample is adequate, then mean of sample becomes equal to the mean of population. Here, the mean of population mu is 220. Now it will be equals to the mean of sample. Okay. So the mean. So firstly, I've created this normal distributed curve because sample size, we know it is more than 30. So whether the population is normally distributed or not, my sample size is adequate. So it will be normally distributed. So now can we see that the mean is 220. Okay. Now we have to check whether uh, the average horsepower is below 217 or not. Okay. So 220. So obviously 217 will be on the left hand side here. So I need to find out this probability, this red area. Okay. So what is the probability? So for this, uh, we have mu is equals to x bar. Sample mean is also 220 and standard deviation of sample will be equals to the standard deviation of population divided by under root, sorry, square root n is sample size. So standard deviation of sample is 50, sample size is 100. So if we calculate it, so standard deviation of sample will be around 1.5. It will be 1.5. Now we have the population, we have the mean, sample mean, we have sample standard deviation, and we know the x value, x-axis. So now we can easily, by using CDF function, we can calculate this probability. Okay, so uh, let's do it on Jupyter Notebook. This is the question, same question. You can go through it once again. So it's so simple. I have just, I have imported skype.stats as st, then st.norm.cdf. Simple. The same coding we used earlier. .cdf. Now we want the x value is 217. Okay, we want probability till 217. Then we provided the mean and we provided the standard deviation of the sample. Now if I run this, the output is 2%. So there are only 2% chances that uh, when the buyer, the potential buyer will check 100 engines. So Sample mean will be less than 217. There are only 2% chances. So the company Mercury, they are at a good situation. Okay. Now let's check another question. Suppose during an hour in a large departmental store, the average number of shoppers, the footfall is 448, with the standard deviation of 21 shoppers. 21 shoppers plus minus can be possible. Okay. Now, what is the probability that a random sample of 49 different shopping carts, randomly, they will pick different 49 hours as a sample, it will give us a sample mean between 441 and 446 choppers. Okay, so again, we have to find out the probability. So here, uh, the sample is 49. We all know sample is 49, more than 30, it is adequate. So this is the 448, this is mean, standard deviation is 21, and we have to find out this red area, 441, between 441 and 446. We have to find out the probability in this area under the curve. So it is very simple. Again, sample mean will be equals to population mean. Okay, that is as sample size is adequate, and the sample standard deviation will be standard deviation of population, that is 21, divided by under root the sample size, that is 49. 49 different hours, 49. So the output is 3. So when we have sample mean, we have sample standard deviation as well, and we know we have to find out the values between 441 and 446. So what we will do? Firstly, we will calculate the probability from here, from y-axis till 446. That will be my A. Then I will calculate the value from y-axis to 441. That will be B. I will do A minus B like this. st.norm.cdf 446. Mean is 448. 448. Standard deviation is 3 for the sample. We have calculated. Minus for 441, 448, 3. This is my answer. Let's check in Python. Now see, this is what we have done. And if I run this, 24%. Okay, this is 24%. Is it clear? Okay, so let's move ahead with another question. Now see, Comcast, the computer services company. Okay, and they are trying to invest heavily on online television services. As a part of the decision, the company wants to estimate the average number of online shows a family of four, a family of four would watch per day. Now, a random sample of n is equals to 100 means sample size is adequate, more than 30. So sample of n is equals to 100 families is obtained, and in this sample, the average number of shows viewed per day is 6.5. Average is 6.5, and the population standard deviation is known to be 3.2. So population standard deviation is given to us, but the average is given, the mean is given of sample, that is 6.5. Now construct a 95% confidence interval for the average number of online television shows watched by the entire population of families of four. Now this question is little bit tricky. Okay, there's a difference between the previous questions and this question. Now go through this. N is equals to 100, sample size. X bar, sample mean is 6.5. Population standard deviation is given, that is 3.2. Here, sample information is provided, and we have to find out the population mean. And to calculate population mean, some other information is given. Population mean is not given this time. We have given sample mean. We are provided with. So what is that another other information? That is 95% confidence interval. Okay. So this in this query, it is asking that construct a 95% confidence interval. Here in this case, earlier what was happening, we were calculating the values for x1, x2, okay, and using CDF function, we can find out the probability. But here it is reverse. Here probability is given. This area is 95%, 95% confidence interval. This is 95%, and we have to find out these values of x. So it is totally reverse of CDF function. In CDF function, uh, what we were doing, we were giving the value of x, and then we were getting the probability till that value of x from y-axis. And here we have already probabilities provided to us, and we have to find out these values. How we will solve it? So here we will introduce the new concept, that is standard normal distribution. So standard normal distribution is nothing. It is any normal distribution we can convert into standard normal distribution. And in this standard normal distribution, mean is equals to 0 and standard deviation is equals to 1. So now what we will convert, what we will do, we will convert this x-axis into z statistics. Okay, so we will be having two values for z, the minus value and the plus value, because mean is 0. If I convert it into standard normal distribution, mean will be 0. So the value to the left hand side it will be negative, value to the right hand side it will be positive. Yeah. So this is how we will use it. We will be having these two values, and we have to find out the mu of the uh, uh, population. Okay, so we know the formula. Okay, so we will convert. This is the formula of our jet test. Okay, so finally, if we convert it and we want mu, so I will get this formula. So here I have given plus and minus. So why plus and minus? Because I want both the values for the positive mu, negative mu. Okay. So given is x bar is equals to 6.5. X bar is sample mean, and the standard deviation of population is 3.2. Sample size is 100. We have to find out the value of z. To find out the value of z, we need to learn a new function. Earlier, we were given in CDF function, we were providing this x value and we were getting the probability till x value. But here we already have probability and we have to find out the x value. It is totally different. So probability is given, that is 0.95. Okay. And we have to do inverse of that. So if this area is the blue area is 0.95, 95%, and it is a two-tail test, two-tail. So see, so both the tail will be the total area of both the tail will be 5% because the central area, this area, blue area is 95%. So this area plus this area, left tail and the right tail, it will be equals to 5, remaining 5%. And if I divide it, it will be 0.025 at both the ends. And here we will use the PPF function, that is percent point function. When percentage is given to us, this 95% is given to us, and we have to find out the points, these x points. Okay. So percent is given, we want to find that point, that is percent point function. So it will take probability area and give us the value of x. Okay. So instead of x, we have to give probability and we will find out the value of x. But we need to convert uh, the x-axis into z statistics. And if we do calculation, we will uh, I'll do it on. I'll create a separate video for that. If we convert it into standard normal distribution, then mean will be equals to 0 and standard deviation will be equals to 1. Okay. Now, how to use it? How to solve it using Python or Jupyter Notebook? Now see, this is the question. Import skype.stats as st. Import math. Why I've chosen this math? Because here we will provide this area 0.025. Mean is 0. Mean is 0 because we have converted it into standard normal distribution and standard deviation is 1 in that case. So to find out the value of z, I need to make a square root as well. Math.sqrt. I need these mu1 and mu2. Okay. See, x bar. X bar is uh, sample mean. PhD, population standard deviation is 3.2 given to us. Sample size n is given to us 100. So from this, I will calculate the Z statistics. Okay. And I will put this Z statistics two times. One time it is positive, one time it is negative. So finally, I will get mu 1 and mu 2. Are you getting me? So to make a square root, I need to use this function math.sqrt, and this function I can use once I have imported math, this library I need. Okay, so what I'm doing over here, let's see. This is what we are doing. Mu we have to calculate x bar plus minus z and then standard deviation. So this is the formula to calculate mu. But to calculate mu, firstly I have to calculate z. And how I will get the value of z? Through PPF function. Okay. And here I will give this value 0.025, this area, this probability. So I will get this value. So now see. Z is equals to st.norm.ppf 0.025 because it is standard normal distribution. So mean is 0 and standard deviation is 1. Okay. Then mu1 is equals to x bar, the formula which we created, sqrt for square root of n, and then finally I will print mu1 and mu2. So let's run this. What is the output? Now see. Mu1 is 5.87 and mu2 is 7.12. So one more thing I need to discuss, that when we have to convert it into Z statistics, when we have to convert it into T statistics. So there are two things. If sample size is more than 30, then we can use Z statistics. But if sample size is less than 30, in that case, Z test is not too much robust. So in that case, we will use T statistics. Another thing is when now see, population standard deviation is provided to us. In that case, we will use Z test, and in most of the cases, as we all know, it is very difficult to find out the population standard deviation. So in most of the cases, we will get the sample standard deviation. And when we have sample standard deviation, in that case, we will use t-test. Okay. But in t-test, when we will apply this PPF function, percent point function, here with this, we will not give mean standard deviation. We will give degree of freedom. Okay. For degree of freedom, I've already created one video in my R uh, data science with R. Okay, but I'll share another video. Okay. So let's take an example with t-test. A stock market analyst, okay, wants to estimate the average return on a certain stock. Now go through the question again. See, I recommend that go through the question 2 3 times. Try to understand the question first. If you are clear with the question, it will be very easier for you to find out, means to create a flow diagram in your mind that what you have to do step by step. So a stock market analyst wants to estimate the average return on a certain stock. Now, a random sample of 15 days gives an average return of X bar, that is 10.37%. Okay, so this is sample average and a standard deviation of 3.5%. Now, assuming a normal population of returns, give a 95% confidence interval for the average return on the stock. The question is same. We have to give 95% confidence interval. Okay. But here, what we will do, everything is same, but uh, two things. Number one is this area is also same 0.025. Here we will provide degree of freedom. Uh, Now, what is degree of freedom? Let me explain you in very. Uh, Let us suppose we have variable x1 plus x2 plus x3 plus x4, and it is equals to 100. Sorry. So we have one, two, three, four variables, and we have not assigned any value to these variables. Okay, all these are empty. We will assign values, but the total outcome it should be equals to 100. Now, if I'm going to assign any value to x1, let us suppose any value. If I apply assign 121, now plus x2 is empty, plus x3 is also empty, plus x4 is also empty, and finally we want output 100. Now in this case, when all the values are empty, I can assign any value to x1, 121, 900, 10,000. I can assign any value. So this variable x1 is having a freedom to have any value. I can assign any value. Variable 1 is free. In the same way, once I have assigned, now I'm going to assign values to the x2. Now x2 is also having freedom. I can assign any value to x2 as well. Let us suppose I can assign minus 65 as well. Any value. X2 is also having freedom. Now, if I'm going to assign any value to x3, again I'm having freedom. 879. I can assign this value. So these three variables, they are having freedom. I can assign any value, but once these three variables are freezed, x1, x2, and x3, now x4 is not having any freedom. It should be exact value so that finally we will get 100. So it is not having freedom. So how many variables are having freedom? If we have four variables, then three variables, x1, x2, and x3, they are having freedom. So when n is equals to 15 in our case, so sample we are taking simple one single sample. So that is why it will be n minus 1. 14 variables, they are having degree of freedom. Otherwise, one variable is not having degree of freedom. So here, for the example, x1, x2, x3, they are having freedom to get any value, but x4 is not free. One variable is not free. So n minus 1. Are you getting the point? So here, either you write n minus 1 or either you write 14. It will be same. Okay. So let's run it. So this is our output. Okay. For the 95% confidence interval. If I write 14 also, and if I run, again I'm getting the same output. Okay. So this is how we can optimize normal distribution, the central limit theorem, uh, the cumulative density function, the percent point function to solve our real life, real world scenarios. Okay. So if you have any doubt, any point you want clarification, you can comment me. Okay, you can drop a comment. I'll get back to you soon, very soon. Okay, thanks a lot. Bye bye. Take care.